In this tutorial, we will learn how to aggregate and segment data using R. So when we talk about aggregate, we're talking about abstracting data to a higher level of analysis. So instead of summarizing data for each employee, we might summarize by group or unit or something like that. And this is also a tool we can use to segment too and decide, do we see, for instance, that employee job satisfaction based on survey results is different between different units of the organization, at least from a descriptive perspective. So in order to do this, we will first need to make sure that we have RStudio open, then go to File, New File, RScript to open a new RScript editor, and let's just do a quick save as to save it as something, just to be in the habit of this. So I'm going to save it as test. I'll overwrite the existing one, and again, the focus of this is on aggregating or segmenting data in R. Okay, so as an initial step, let's set our working directory. If you are unfamiliar with what that means, check out the tutorial that covers that. So next we'll use the setwd function to set the working directory. Mine is my H drive R workshop, because that is where the data file called employee survey data, which I'll show you in a second, lives. So I'm going to run this by doing a Control Enter because I am working from a Windows version of RStudio. We see that it worked here. Alternatively, you could go to Session, Set Working Directory, and choose Directory to do this. And next we want to read in the data. So what are the data called? Well, it's from a data file called Employee Survey Data. So if we go to my working directory folder here, we see Employee Survey Data here. I'm going to copy the exact name here. See, it's a comma separated value or CSV file here, so remember that. And the next thing we're going to do is make sure that we've installed the reader package, which has within it the read underscore CSV function that we are going to use. I've already recently installed the reader package, so I don't need to do that again, but I do need to use the library function here with the reader package name as the sole argument, run that line of script. And then the next thing that I need to do is actually specify the name of the data frame that I plan to read in using that read underscore CSV function from the reader package. And so I'm going to call this serve data for survey data here and use the left-handed arrow to note that I'm naming this data frame that I'm reading in. The object will be called serve data. And I'll use read underscore CSV as the function of choice here. And I previously copied the exact name, so I'll paste here that exact name of employee survey data.csv, the file name. Make sure you add the .csv extension here within the quotation marks, and let's click run. Okay, so let's click on the data frame just to get an idea where we are. Okay, so note a couple things. One, we have a number of different variables here listed at the employee level. These are survey responses, let's assume. And let's assume that we've matched the employees to with their supervisors, as well as the employees noted which unit they were from, or rather maybe we merged that data for them here based on their employee ID number. And so here you'll see there's employees from marketing, HR, and so forth. So we're going to do most of our aggregating and segmenting based off of this unit variable here. Okay, so the first thing that we want to do is we're going to be working pretty extensively with the dplyr package and some of its functions. So be sure to first install the dplyr package if you haven't already. I recently updated mine, so I'm not going to run this line, but you might need to. And then I'm going to use the library function here to access the dplyr package. Plyr. And I should note that if you start getting error messages, sometimes it means your package is out of date and you should reinstall them. I recommend doing this fairly regularly, sometimes on a weekly basis if it makes sense. Okay, so I'm going to run the dplyr package here to access it using that library function. And the first thing that I'm going to do here is let's describe or summarize data in aggregate. And so what I want to do initially is let's count the number of cases. Well, let's not use the hashtag here because that means something else in R, but number of cases per group. And actually, let's say unit here because that's the name of our variable. So I want to know how many employees who responded to the survey are within each unit, marketing, HR, and so forth, okay? So the way that we can do this is it's much easier to use this with pipes, the pipe operator, because dplyr is built in part on the Magrittr package, which uses pipes where you can pipe a data frame or an object or a value to another series of functions, and we'll actually be linking multiple functions together using this. This is a really good example of why piping can be so valuable here and so efficient and easy to read too. Okay, so the name of our data frame, let's start off with that, is serve data. And then we're going to pipe this data frame using our pipe symbol here, which is %sign greater than %sign. So this is our pipe right here. And the next thing that I'm going to do is I'm going to actually start a new line here, okay? This is more conventional when we're writing our script with pipes here. So I'm going to use first a function. So I'm piping serve data to a function from dplyr that's called group_by. So we're going to group by. And specifically, we're going to note what we're going to group by. So we're going to group the data by the unit variable, okay? So this is the unit variable here that we're interested in grouping by. Now we're going to pipe this now. So we've piped the data frame into the group by function, and now we're going to pipe the results of that into the summarize function, which is also from dplyr. And we're going to create a new variable, or we're going to create a title for our count variable here. Okay, it can be whatever you choose. I'm going to call it unit count. And I'm going to say equal to, and then use the in function, which is a count function here, and just keep the parentheses empty. There's no arguments we need to put in here, but the name of the function is lowercase n. And so watch what happens when we run these 3 lines of script here. Well, now we've got a nice count here, and in terms of how many employees are in each unit here. Now, truth be told, we could just run the regular count function on the So if we take and pipe the data frame into the count function here and just put the name of unit as the variable name here and run this, we'll get something pretty similar down here. We just don't have that unit count title over this. Now, this is just to illustrate this way that we can link these together and why grouping might be valuable here though. So another way that we can do this, and this other way will come in handy as well, is let's copy these exact lines here and just tweak them slightly. There's another adaptation to this that we can use that can also be quite valuable. And I just want to show you another function here. And so the name of this other function, instead of in, it is in distinct. Okay, so it's the number of distinct values. And here we actually do enter within the parentheses something that we can use to count the number of distinct values. Okay, and so in this case, we have mostly unique employees. So it looks like all these employees are probably unique employees here. But what we can do is let's actually put in the supervisor here and see how many unique supervisors we actually have. And so the name of that is just supervisor. Okay, so that's their unique ID. Okay, and now let's run these 3 lines here. Okay, and now we can see how many unique supervisors are in each one of these units here. Even though we had some obviously there's multiple counts here. Now watch what happens if we replace this with that employee ID variable. So this would be how many distinct employees do we have in each unit. And this will actually be pretty much identical or exactly identical to what we did above, because each employee only filled out the survey once. Okay, so the next thing that we're going to do is we're going to calculate descriptive statistics, such as measures of central tendency and dispersion and so forth for relatively continuous variables, or those variables that are on interval or ratio measurement scales. Okay, and so in this case, we're going to we're going to stretch a little bit, and this is fairly customary with social science. We're going to consider the job satisfaction and all these variables here that are Likert type scale responses, let's assume, that are 1 to 5. We're going to treat these, instead of being ordinal, we're going to treat these as continuous for the sake of demonstration here. Okay? And so the first thing that we're going to do is we're going to use the same type of script we were using before. So let's copy this again, and we'll just tweak this. Okay, so we've got the name of the data frame. We're piping it into the group by function here, group underscore by, keeping unit as the grouping. And then the next thing that we're going to do is we're going to pipe that into the summarize function. And then let's actually, instead of doing a unit count, we're actually going to do the mean or the average for each group of, let's say, that first job satisfaction variable. And so I'll just call this mean JS for mean job satisfaction. I'll delete the in function here. And now I'm going to use a base R function that you might have learned before. That's just the mean function, all lowercase. And here I will enter the name of this variable of interest, which let's say is jobsat1. And then I'm going to put na.rm equals true as the second argument. And what this says is go ahead and calculate the mean even if there is a missing value or more than one missing values, okay? And so here we've made this little tweak here, and we can run this. And now we've calculated the mean for each unit here, each level of this unit. So the mean job satisfaction for human resources is 3.18 and so forth. Okay, so you can start visually seeing this through the table. Now, we can also extend this so that we can run more than one summary statistic at a time. So I'm copying this and pasting this here. And so let's, between these two parentheses, let's add a comma so we can add a second argument. Let's do mean of, let's just say we're doing turnint here. Let's just say mean underscore TI and then equals, and let's copy this here. And we'll do turnint1. Okay, and then let's add one more. And this time though, let's do the standard deviation of job satisfaction 1. And so we'll do the SD of job satisfaction 1. We'll copy the exact same arguments here that are in the parentheses for that mean function because the SD and the mean function take the same arguments. Okay, so now we're going to create a table with four columns, but 3 that are going to be meaningful for us in terms of calculations. So let's go ahead and run that. Okay, so now we can see the mean of JS for each unit, and then we can also see the mean of turnover intentions and also the standard deviations. And so you could go through and apply different functions here to create this. Now, thus far, we've been doing this just to view this in our console. If you wanted to actually create a table, or in this case with dplyr, it's actually called a tibble, but it operates mostly the same, you would, and this can also serve as a data frame in and of itself too. So you can actually do further analysis on this if you'd like. But if we copy that and paste this below, we can actually create a new data frame just by doing this. Let's say ag serve data here. And so we're just using that left-handed arrow to name this, and now we can run all of this together. Okay, now we have a new data frame here called what we named it. So here we go. And this would be really helpful if you were trying to just look at unit level descriptives or something like that, or aggregate data to the unit level for subsequent analysis. Okay, so there is another, let's say we can use the psych package and the describe by function. So previously you might have worked with the describe function, which describes just everything in terms of descriptive statistics in your data frame, but we can also use a function from the psych package called describe by, which will describe by a certain grouping variable. Okay, so what we're going to do is first, if you haven't already, install the psych package. I'm going to write this out so you can see it, but I'm not actually going to run it because I've recently installed this, but I will use the library function with psych as the argument and run that because I do want to access that psych package so I can access the describe by function. So the describe by function starts like the regular describe function we would use in psych, except then you're going to do a capital B and a Y for describe by, so it is case sensitive there, like anything in R. And the first argument is going to be the name of your data frame. So let's do the original data frame, which was serve data, comma to separate the arguments. And then we need to do group equal to specify what variable is going to be our grouping variable. And in this case, we need to then re-specify the name of the data frame, so serve data, and use that $sign to then note that the unit variable belongs to this data frame here. So the dollar attaches that there, okay? And so now let's put our cursor there and click run. Okay, so what you'll see here is a lot of output. And if you scroll down, you'll see that we've now grouped the descriptive statistics by each level or category or group of that unit variable. And so you can see coming through here, now there's manufacturing, marketing, research and development, sales, etc. So that's one thing that we can do. Now, what if you would like to add a new variable? So thus far, we've just been summarizing things, but what if you want to actually create a new variable using this approach? Well, to do so, we can do this. So if you, to create a new variable, let's say it's a new count variable. Well, here's what we would do. Let's go all the way back up to the count that we created here. Let's copy this. And so here we have our data frame. We're piping into the group by function, saying we're going to group by unit. And then we're going to summarize and create a new variable, and summarize by unit count. Well, if we change this to mutate, so this is another function from dplyr. And what we're doing now is we're actually going to, instead of summarize, we're going to mutate and create a new variable called unit count that will be based on the number of unique cases within each unit. So, and one thing that we also need to add though, is we need to do another pipe here, and then we need to do ungroup. So we need to finish this off, pipe everything back into an ungroup here. And the reason is that once you group something like this, the data will stay grouped, the data frame. And so we want to make sure that we ungroup it. And so we also want to make sure that we name this something new, or we can override the existing data frame. So let's just override the existing data frame by pasting that data frame here using the left-hand arrow. So we're going to add this new variable called unit count that will just be the counts to this existing data frame. So let's run all this. Okay, and now let's take a look at our serve data frame here. Scroll all the way over to the right. Okay, so now we have unit count. So now for each individual case, we can see that, oh, they're in a variable, or their marketing department has 19 people. Why might you do this? Well, there's actually some statistical software programs that prefer the data to be aggregated ahead of time. And even within R, there's certain packages, especially when you get to multi-level modeling, where this would be useful. Okay. So the other thing that you can do too is you could apply other functions to here, just like we did above using mutate, like calculating the mean or something like that, is something that you could also do if you are interested in creating an overall variable. So for instance, if we adapt this a little bit and we say, let's say we're going to do mean JS, and actually let's just borrow from this. Let's just copy that whole line there, paste in here, and let's run this. So we check on our data frame again. We'll see now we have that. We can also do it with descriptive statistics too. We have that new variable added to our data frame. Okay, so lastly, let's just talk about a quick way to visualize by group or segment. So without getting into too much detail, let's say that we want to visualize by what variable do we want to use here? Let's say it's JobSat1 is what we'd like to visualize, and except we'd like to visualize it by unit, okay? And so let's install, if you haven't already, the lessr package. So that's less with a capital R. And again, I'm not going to run that because I've recently done that. And then let's access that package of less_r using that library function, as I note here. And I'm going to run this line, though, for the library function. And then let's use the plot function from lsr to create a VBS plot, a violin, box, and scatter plot here. And so the first thing we need to do is enter the name of that one of those jobsat variables. Let's do jobsat1. And then data equals to specify the name of the data frame, so serve data. And then we add an argument by1 equals, and this will introduce a trellis or a lattice structure. And so this is where we can put our grouping variable in. So let's do unit here, which again is our grouping variable we've been using from the data frame. So let's make our plot window big enough here, and then click run. Okay, so now this is probably because I've blown this up so much, but now you can see the different units here, and you can see the distributions of the variables here for jobsat1 across the different units. So it's a nice way to visualize it. So this wraps up how we can aggregate and segment our data in R. Thank you.